literature senior, so then.
Yep, they still think it.
Really? I don't know.
Anyone decided not to bring homework today? Okay, so means everyone did bring it. I'm impressed. I'm impressed every time. How organized people can be. Really?
What's 6? Yeah, for the very left. You mean 5?
How do you like this homework? Was it like easier?
It's shorter, yeah. I like that a lot better. The last one, the very last extra credit.
Oh, I didn't do that one.
Yeah, I
know. Started.
I just didn't want to get
I'm written down, yeah. Just like, I gotta go back.
Yeah.
You didn't.
Yeah, I was like, I hope people would, I was like, when here.
Tech support. I asked to project content of computer.
That's everybody.
I'm to finish that code report, but it's really like almost finished it on Sunday, and then haven't done a single thing to it for 3 miles.
I just started this morning. And I got,
It's a shorter one. It's so
it's
nice.
not
I'm at like 3 pages and I'm almost done. And I'm like, this is gonna be super.
I that's a long start. It's like you need to experiment.
No, there really not much.
Oh, yeah.
I just copy and paste from the last one. There's no reason to change it because I'm not going to hang on.
I was in a rush of preparing today's slides. Otherwise, I would put a little gift from Joy. He found a photograph of a light Schrödinger cat that would match content of the course.
No one on track section today. It's on. Track. Oh, I can't even find the track. Dude, did you only do track for 1 thing? Why do you stop? Just I need research and I've always been in my productive. Makes sense. There's a lot and I think one thing. When you do why doesn't I like my oh
Almost done.
no so I just like I'm talking coaches, but like there's 2 coaches and that is basketball coach in high school and the head coach to track in college. I did the decathlon by the way. Yes, huh? I haven't done that yet, no. I was with the abstract and keywords last.
Anyone of you submitted the application for NSF funding? GRFP? No. So plan. I need to give the handouts as well.
I just
There,
I just have to fill in the DSC.
about a week before the end of October each year, there is a deadline to apply for like 40K per year. And last year of undergraduates is the best time to apply. first year of graduate school is also good, but just bringing it up. Did I told it to you before? So please practice the role of grader.
One of them.
This would be beneficial, of course, for me to save my time, and for you as well, for seeing success or failures of others, especially when names are hidden. You can avoid similar failures in your next practices and copy similar. Is it you?
No, it's not me.
Because I pasted
I think I know.
something on the top of a name, and now I do not recognize who it is, so I will not be able to.
Okay, I was like, I recognize this hand.
Yeah.
I wonder who that one is.
Yeah. I don't know.
Blame me
Fuck
for
this guy.
not making
Zeros.
effort against this.
Look, I got negative. I don't know what he was doing.
Negative 100.
This guy got negative. None.
So please enjoy and entertain this role. I will go over the stuff here if the key is not complete. So we will call today's meeting primarily problem solving, and maybe there will be continuation of weather operator in discrete ways if time allows. Here is a really important thing that everyone is encouraged and invited to present next Friday, right? Not next, coming Friday, just in 48 hours. And there is a thing that if I would be in class, I would start to hate instructor. So there will be a next homework based on your
What's next?
digest, yes. So when you listen presentations of each other, you will digest it, and on Monday you will bring a little notes what you understood on each subject. Right? It's about a sentence about each statement. 10 sentences or whatever, it doesn't, it's not hard. And then in a week later, there will be another theoretical homework, but no, there will just take a week.
Yeah, Dimitri.
Yes.
You go back one.
That's
We don't have class that day, the 12th.
because it's veterans.
What?
They moved it from the 5th to the Monday.
No class on November 12th?
And then, yeah, the 12th.
Sure. 12 plus 1 plus 1, 14. Thank you for bringing this up. 18 was... Yeah, sure. Thank you for and it will be appropriate because this one is... No, it's not the hardest one, but still it's good to have time, extra time. So there is also 20 points plugging in by not into Schrödinger equation. So here are the points, and I think everyone is happy and consider this homework as easy, but still, if you see some shortcomings, be generous, give each other benefits of doubts. So the first one was just plotting the figure. If someone plotted it with computerized tools, it is fine, but it is much more fun and much quicker to do it just by hand. So you find how to plot functions, and this looks like we have an expert in the audience. Michael? How many times, how many minimum and maximum here?
On the bottom one?
Yeah.
4.
So which eigenstate of the harmonic oscillator it is?
4.
That's right. So it's fourth state or third excited state, right?
Yeah.
Okay, good. So, and typically they have a shape of polynomial times exponential, and if one needs to draw a function, one finds the roots of polynomials, takes out a bracket, solving for square, finding roots, and wherever polynomial has roots, the function intersects the x-axis, right? And then you just draw rough function that intersects zeros and make sure it is also asymptotically approach zeros at the plus or minus infinity. How many points for this one?
That one was 10.
10? Yeah, sure. So if you were taking calculus or reading some text in calculus, you may have seen this Rodriguez equation, which is a mathematical tool to generate polynomials. So if you have derivative of nth order in between and exponentials of minus square and plus square before and after, depending on the order of the variable, you will get like trivial polynomial, just flat function, linear raising first power of independent variable. Next order will be square, next order cubic. And actually, the goal of this assignment was to show an alternative mathematical way to generate eigenstates of the harmonic oscillator. There are theorems that show that if you set up this sequence of polynomials and then you remove this, if you multiply it by Gaussian function, you will see the same shapes. So there are several alternative ways, like about half dozen, how to solve for harmonic oscillator, and this is one of them. So this is about 25. So if answer is correct, give full credit. If the trend of getting polynomials of increasing order is caught, withdraw just, but not the coefficients are not literally, they're just withdrawable. So the next one is an illustration of the concept of raising and lowering operators that you may have memorized forever. So that there is a operator which is either differential or in matrix form. When applied to a certain state, the raising operator goes to the next state, lowering operator goes to the lower state. So if one would start from the first excited state, linear times Gaussian, and then one applies this combination with minus and plus between position and derivative or position which is similar to momentum, right? You'll see that once one is getting decrease of the power in front of polynomial. So from this linear stuff, one would get the only Gaussian function. And this would correspond to lowering operator. And in another exercise, one is expected to get the polynomial of higher order, the quadratic polynomial, right? Which would correspond to raising operator and going to the second exciter. So again, if this trend of changing the order of polynomial is caught, give substantial credit. If it is exact answer, give full credit. and give additional credit if someone verbally declared analogy between these differential operators and raising and lowering. Okay? So next one. There is nothing wrong with this assignment as a homework in practice, but if you would need it for real life, for connection to operators, one would need to remove the imaginary unit here. So if you put two objects that look like creation and integration operator and you multiply them by each other, open brackets, one would see that there are three, or actually four terms, but they can be combined. So one term will be quadratic, which looks like potential energy. Another is second derivative of a space, which would look like kinetic energy. And then there is a commutation of derivative and position operator. So if this is analyzed, doesn't represent any observable. So if only brackets are opened, give half of credit. If there is an attempt to make connection to kinetic potential energy to Hamiltonian, give full credit. So operator constructed of this superposition of position and momentum, which look like creation and annihilation, would reproduce the Hamiltonian plus some constant that comes out from the commutation. 30. So, how many works that you're grading show more than 2 examples? Everyone. How many shows more than 3 examples? How many shows more than 4 examples? How many shows more than 5 examples? No one? Okay, so 5 is maximum number. Okay, then prorate. 5 examples, 10. 4 examples, 8. 3 examples, 3, right? The main example of harmonic oscillator is vibrating atoms in molecule. Another one is vibrations of the dipole polar molecules in solvent. Probably everyone mentions ball and spring or like pendulum for the cool wall clock. There is a LC contour for transmitter and receiver in electronics, electric field in light and in lasers, and there are some more exotic oscillators like chemical oscillators, the model better. So the target for the A grade is 100, but there is a chance to get more than 100 if please raise hands if the work that you're grading includes extra credit solution. Oh, okay, perfect. So the goal is to normalize second excited state of harmonic oscillator, and we discussed in class that one needs to make it square, open brackets, integrate, and there are 4 integrals. So the simplest one will be square root of phi, the next one will be 2 square roots of pi, and the fourth one will be 3 square roots of pi. Or I do not remove this 4 and 4 constants. So if one plug them in, it will be 1 equals this normalization squared times square root of pi over alpha, where alpha is our notation for square root of mass, frequency, and Planck constant, right? And if one solves for normalization constant, it will be square root of square root. Right? This is the standard shape of the second excited state of harmonic oscillator. I don't know, is it too much or not, but it's relatively heavy calculation. Let's give 40 points to those who completed it completely, and some partial credit if there was a good effort. The integrals here, let me show, because the integrals there, you just submerge psi under differential, and then it will be trivial, even indefinite integral. And this I2, one can play integration by part, assuming that this psi times exponential is v, and this that you can submerge under differential, and this psi is u, and then one can take it. So, and I do not have answer key for the extra credit last problem, number 7, but the answer should be 1/2 of the H bar omega. If you see it, give another 20 points. Do you need more time to complete, or everyone is done? So, please add together the grades, put them on the front page, and circle.
Do you think I just created that killing around that homework? Or I just created this stuff and killing around that homework? Really don't know.
I knew that everyone will progress really well at this point.
I don't know who's my favorite, though.
No.
Just color it up.
Completely anomalous.
There is a really good trajectory for successful completion.
Sorry, I didn't get you.
So, do we have more time to play some more lecture material? Probably yes. So, what should I show for lecture material? Where are we going to? Let's discuss and recall, because without strategic understanding, there is no much reason to practice math or whatever. So, predicting future.
We're making discrete the rated and lowering operator.
Yes, excellent. But why are we doing so?
So we can predict the future using computers, and they don't have to spend like $300 to try and calculate.
Okay, yes. So we want to practice quantum mechanics without wave functions, right? So if we convert the differential operators into matrices and convert wave functions into vectors, into a set of numbers, equation would take a little larger space on the page, but actual calculations will be so much quicker. Yes, it will be not very compact. Instead of writing short differential operator with like ddx, it will be like matrix. Right? But for practical calculations, it always looks beneficial. So, eigenstates, weather operators. It looks like we got this one, right? So So creation operator matrix element is delta function that will parse lower subdiagonal, and there is a index increased by 1. This should be the last equation from what we have seen on Monday. Have you ever seen diagonal matrices before? Yes? Have you ever seen 3 diagonal matrices before? Probably yes. Any matrix 2 by 2 is 3 diagonal because there is nothing else. Main diagonal, one upper subdiagonal and lower subdiagonal. And very often, if one converts differential operators into matrices, the 3 diagonal matrices come up very often. So everything is 0 except main diagonal and 2 subdiagonals. When we were discussing shape of momentum operator in Cartesian discretization for the left, remember it had this only things near the main diagonal are non-zero. So it is standard situation in most practical calculations. Here it is even simpler. Everything except one side. Let's guess how would the annihilation operator look like.
Oh, is it the upper diagonal?
Mm-hmm. Yes. Good. I'm not sure. We can carefully check, but probably it will start not from square root of 2, but from square root of 1. Square root of 1, square root of 2, square root of 3. So if we put A without dagger and matrix element, there will be zeros here, and square root of 1, square root of 2, square root of 3. So by now it is just a little mathematical exercise, but we are going to get some pleasure, as much as one can get pleasure out of matrices, some practical use, some benefits. And the goal for this thing is to develop quantum mechanics without differential operators, without wavefunctions. So we already know how to express wave function, how to reproduce wave function with a set of expansion coefficients, how to go from continuous distribution into a set of numbers, into a set of coefficients, discrete vector. We already know how to express raising and lowering operators in the discrete form. But in order to have a fully operational analog of quantum mechanics, we need such, what is a main operator? Main operator that everyone needs when starting any quantum calculation.
Hamiltonian?
Yes. So would you agree that we need to convert Hamiltonian into discrete form? Right? So if we would convert Hamiltonian into discrete form, then our time-independent Schrödinger equation and time-dependent Schrödinger equation will be stored in form of matrices. Good. How are we going to do it? What is the plan? What could we do? Let's make maybe a more ambitious plan that we can complete in the remaining few minutes. So, can we do something based on the completed homework? Let's check the problem. Number 4. So let's look at it and try to interpret. What do you see there? So if we multiply two operators which look similar to creation and annihilation operator, we should get something similar to Hamiltonian, right? So it's a good thing to try, and probably it is what I would try to show today, right? This was your discovery during your homework practice. Are there any other ways to convert Hamiltonian into discrete form? Any ideas? This is not trivial question. If no one is answering it, there is nothing wrong. So what is the definition of creation and annihilation operators? Do not reproduce all constants, just try to tell generally what is it.
Raises or lowers the excited state by 1.
It is, yes, it is like definition of how they are functioning, right? Their practical use. But how are they defined mathematically, what they are equal to? Before we went to this discrete representation. How do they look? Yes?
The sum or difference of the position and momentum operators.
Yes. So let me show something excellent, which I will not practice on this lecture, but I really want to show you just as an idea. So if your A and A dagger are some constants, I hope I'm right, but I always make mistakes. So the raising and lowering operators are linear combinations of position and momentum. What if we add and subtract these two equations from each other? What if we add together? So on the left you will get A plus A dagger square root 2 m omega x. And what would happen with the second term? Cancel. That's it. So now if we divide left and right by this square root and 2 m omega, it will be position operator expressed in terms of raising and lowering operators, right? You see. And now if we want to define potential energy, we will just tell potential energy equals m omega x squared divided by 2, and plug in this summation of creation and annihilation operator instead of x, right? And then we can do, if we subtract these two operators, we can formulate momentum operator and use it for definition of which energy?
Kinetic.
Kinetic, yes. Right? So it's one way. This is mostly like traditional, canonical, logical, but it is long. And in this course, we are becoming masters of shortcuts. So I would like to prove And not I. You guys have already proved in your homework. If you just multiply these two operators, A and A dagger, we will reproduce Hamiltonian in the quickest and easiest way. How come? If you do the full thing, the powers of A dagger squared, A squared in position and momentum will cancel each other. And the only thing that will survive will be just product, A dagger times A. This was main message. The rest are just mathematical tricks. So, this equation you would support and agree with, right? It is what we concluded on Monday. And since no one was protesting, and since we believe in democracy, this is a correct. No one thought I am against it. Therefore, it is assumed correct. A new way to prove mathematical equations. Very good. Now, the second one is a conjugated. It is what it was inside of Alex who told that it should be upper subdiagonal. And if you write down upper subdiagonal in form of Dirac notation, it will be this expression, which we can accept without derivations. Well, probably we shouldn't accept anything without derivation, but we can get along with it without much protest by looking on lowering operator converts state M into state which has lower index. Converts M into M minus 1. While raising converts N into N plus 1. Going up, going down. So our exercise, or not my exercise, we just lean back, take popcorn and enjoy whatever happens. My exercise will be to multiply these two operators one by another and try to play some tricks for matrix algebra if I write them as matrix, or Dirac notation algebra if we practice this one. You remember about snake and the rabbit. So it will be time, probably it will be time to practice it again. So if you multiply this expression by this expression, there will be chance to develop delta function, and there are a couple of summations that would meet each other. Okay. So for E dagger summation means for A without dagger summation over M square M N minus 1. Well, we always can pull summation to the front, right? It is nothing wrong. Because this summation will anyway affect only these terms that include M. So it doesn't matter for summation over M, these things will be considered only as factors. So once again, summation over M, summation over M, square root of M is 1, square root of M, N plus 1, N, M minus 1, N. What are we doing? In some sense, we are multiplying two matrices. And you know how painful can it be, row by column. But in direct notation, I promise we will, if I do not make a mistake, we will multiply these two matrices in a couple of lines. So we already have a snake as some sign. Where the delta function will come from? So our little goal is to identify delta function in this expression.
Is it in the middle brown cat?
Yes. Everyone can see it?
I don't see it, I just guessed.
And what is the property that will help us to identify delta function here? Let me write it mathematically. Let me use even the same notations. Star index integral, which will be 1 m equals m minus 1 equals m, 0 with m minus 1 is nothing, which will be. So what's the name of this property? Integration of product of two eigenfunctions.
Orthogonality.
Yes, orthogonality, right? Doesn't surprise me. Orthogonality will be either 0 or 1. And in a shorthand notation, it is written as delta m minus 1. So this bra times ket can always be converted into delta function in case these are eigenstates of some problem. If those are good basis states, if they are, and typically we use eigenstates of some quantum problem as basis. So who will be the victim? Who will be sacrificed among these two variables? M or N? I suggest to sacrifice, it doesn't matter, they're equal, but M is longer, it's more heavy to write, therefore let's sacrifice it. So, how are we going to do it? What does it mean, this symbol delta M minus N inside the algebraic equation for summation? Right now, potentially there are, if you go up to infinity here, the number of terms in the summation is infinity squared, right? Or if this is like some big number, this big number squared. But due to this delta function, most of the terms will be zeros, right? Only very few terms will be parsed, will be like multiplied by 1 and allowed to live. Right? So which terms we remove and which term we keep? How do you do it? So we keep only those terms when m minus 1 equal n. Right? Or in other words, m equals n plus 1. Good? So there is not much writing. There is a little more thinking. I don't know what to write and how to write. So we need to keep only those terms that will match this relation between indices. So it means that anytime we do see symbol m, we replace it by n plus 1. Okay? So we will plug it into here and into there. And this term is already removed. We replaced it to delta function, and then the summation over m and delta function will cancel each other. This summation and this delta function will cancel each other by the principle of snake and rabbit. So we will get n plus 1 into here, and n plus 1 into there. Now let's probably flip to the next slide and see what will happen. But look, bra and cat both would include n plus 1 and n plus 1. You see? The factors will include square root of n plus 1 and square root of n plus 1. What will be the result of multiplying square root of n plus 1 times square root by n plus 1?
Plus 1.
Just n plus 1, yes. What does it mean if bra and cat are the same, or cat and bra? Which matrix would it correspond?
Yeah.
Huh?
Yeah, identity.
If the factors up front will be 1, it will be identity. But we definitely can tell that it will be diagonal matrix, right? If you start from state n plus 1, we will end into state n plus 1. We are not changing the number. But the higher the index, the higher will be the factor. And there is nothing wrong. So we will have only summation, factor, and this n plus 1 and n plus 1. There is nothing wrong to replace n plus 1 by new variable k, just because we are lazy to write plus 1 all the time. Then it will be summation over k, this number index here, the cat and bra. And later on, we will need to add 1/2 because of the commutation. But generally, this is Hamiltonian of harmonic oscillator in the matrix representation. Good. On Monday, we will start from this equation, because Friday will be your day of glory. So h bar omega up front, and then 1/2, 1, 2, if you put this 1/2 aside, it will be 1, 2, 3 on the main diagonal, and zeros on the sub-diagonals. Okay, I have borrowed 4 minutes from your generosity. Done, enough. Hope to see some of you on the lab, and for those who are busy with other things, I will send the recordings.
We're just gonna do we're just gonna standardize. All right, so Kaylin, which one of your things am I taking?